Hello everyone, my name is Nathan Noble. Today I will be presenting my project on the Bolzano-Weierstrass theorem and exploring the question, what makes a proof trustworthy? If an AI writes out a math proof and every line of it looks right, should you believe it? Most people would say, yeah, obviously, AI is good at everything. But in this project, we explore that question a little bit deeper. And what I've found is that it looks right and it is right are not the same thing. Today I'm going to walk through the theorem, show you how the proof works, and then talk about what happened when I asked AI to prove the same thing. So here's the Bolzano-Weierstrass theorem. It states simply every bounded infinite set of real numbers has at least one accumulation point. Before that means anything, we need to unpack two things. What is a bounded infinite set, and what is an accumulation point? So here's a simple diagram explaining visually what a bounded infinite set may look like. So if we consider this circle a bound and the dots inside the circle infinitely many points, we basically say that each point is no larger than the value that represents the outer circle. So essentially, we can always find a number greater than any point in the set. Now, what's an accumulation point? This is the key definition of the whole theorem. An accumulation point is a spot where infinitely many points of the set cluster arbitrarily close to this point. No matter how tiny a neighborhood you draw around it, you'll still find infinitely many points of the set inside that neighborhood. You can think of it as a pile-up point. Here is a brief visual. As you can see, there's infinitely many points in this space around this point. As we get closer, there's still infinitely many points. So you've got your bounded interval on the number line, and all the points are scattered inside it. And right here at this spot, the points are piling up, infinitely many of them crowding in closer and closer. That's your accumulation point. And the theorem says, in any bounded infinite set of real numbers, one of these has to exist. You can't spread infinitely many points across a finite region without some spot becoming a cluster. So, how does the proof work? Instead of proving it, I decided to show you visually. You start with your whole interval, so you can imagine that this top line here, labeled from alpha to beta, contains infinitely many points inside of it. If you cut it in half, only two halves, infinitely many points still have to be in at least one of those halves. So, you pick that half, or a half, that has infinitely many points remaining, and we'll label its bounds A1 and B1. Now we do it again. We cut that half in half. Now one side has infinitely many points once again. We do it again. We have A3 and B3, and this continues on for every integer, every positive integer n. And it just continues to get smaller and smaller while still containing infinitely many points from our original set. So, for this project, I also asked an AI to prove the same theorem. I want to be real with you. It was mostly correct. The strategy was very similar to the approach that I took, and it had the correct notation, of course. Now, if I were a student seeing this for the first time, I would probably just believe it, right? But when I sat down and actually went through it line by line, I found some notable problems. Here's the first big thing the AI is missing. Math is not just arithmetic, it's creative. There's an art to writing a proof. There are many different approaches that can typically work for any given proof, and part of what makes a proof good is the choices the person made in building it. How efficiently did they prove the theorem? What tricks did they use? Is it clear? Can the reader understand it? All of these things go into making a good proof. Now, the AI does not do that. It just spits out the average proof of the data that it was trained on, leading to a boring, uninspired proof. Whatever shows up most in its data is what you're going to get. Now, my proof and the AI's proof both used the method of bisection, which I showed earlier, but the AI version was almost mechanical. It felt like it was reciting something instead of really thinking through it. And to me, that makes the math kind of dull. The second issue is that AI skips steps. It'll say some things like, clearly the intersection contains exactly one point. But the word clearly is doing a lot more work than it appears. To many readers, it may not be clear that is the case. It skipped the reasoning of why that is apparent. Another spot I found is that it said every neighborhood contains points of the set other than possibly X itself. The word possibly is sneaky because it leaves some ambiguity. It's glossing over the actual argument. A beginner reading this wouldn't even know to stop and ask why. And this is just what I mean by skipping steps. The AI jumps down the staircase instead of taking it one step at a time, effectively brushing over steps. And if you're learning, you need that staircase. You cannot brush over steps, or else you will not learn. You will just be memorizing the process. You need to see every step because that's where the understanding actually comes from. So in conclusion, here's what I'd say if you're getting into math and using AI for proofs. Are proofs by AI trustworthy? What does it mean for a proof to be trustworthy? I would say that you could probably trust the conclusions AI gives you most of the time. If it's a theorem or a problem that is found in textbooks or commonly assigned in college courses, the AI will most likely get the answer correct. However, with the final answer usually being right, I do not think you should trust the process. So trust the result, but not the process. Don't take these proofs for granted. Do not learn the proofs from an AI, and don't let it skip steps for you. The whole point of math, the thing that actually makes you better at it, is the struggle. Sitting with a problem, getting stuck, and working through it. That's where the learning actually happens. If the AI does that part for you, you get the answer, but you do not get the growth. In math, the growth is the whole point. Thank you for watching. I hope you enjoyed the video.